Welcome again to another edition of the Southwest Climate Podcast. I'm here, as always, with the indomitable Mike Crimmins.
Hey, Zach.
Mike, arms raised.
Arms raised.
You feel good.
Victory. Yeah.
What'd you learn?
I don't know. Probably something, given how our bets usually go.
We'll revisit those bets that you seemingly always win. The monsoon's here.
It is today-ish in Tucson.
Today-ish, by what standard?
By today, it looks like will be the third day in a row of daily average dew points in excess of 54 degrees.
Oh, you're reverting back to the old definition.
I am old school on the dew point definition.
We're going to have to get into it, but we're going to have to recap what happened in June because we had some fireworks mid-month. That was nice to talk about here in Tucson. A little bit of rain.
Yeah,
quite a bit of rain, actually.
Quite a bit of rain. About a week out from our last podcast, yep.
We'll revisit June, revisit some of the bets that you won, talk a little bit about the first part of this monsoon season. And as you mentioned, we are now in the throes of it, thankfully.
Absolutely.
And a little bit of a look forward. I'll get you on record of predicting what the monsoon is going to look like in the rest of July and August.
Taking it day by day. Day by day, Zach.
So June, Mike, the National Weather Service unscientific version of the start of the monsoon, if you will, happened.
It's halfway through the month.
So the official monsoon season started June 15th, as we make note of always. And it just so happened that this year on June 15th, we got
squeaked past midnight, waiting for it, held back at bay, waiting for the 15th.
And we got some rain. We got quite a bit of rain, actually.
Yeah.
At the Tucson airport, close to an inch of rain fell in 2 days at the Tucson airport. And I was upset.
What can I say?
I was upset because we had bet last month on the total monsoon precipitation starting in June 15th.
Starting in June 15th.
And you said 7.5, which is...
It's a good way to start off the season.
So 6 is the average for Tucson's thereabouts. And I was 5.75. And that inch counts for you.
It does count for me.
Which is...
It's after midnight.
If this wasn't...
If it was on the 14th...
child-rated version, I would swear.
If it was on the 14th,
earmuffs.
I'd have to say, sorry. I mean, I'd give it back to you, but I'm not giving it back.
Okay,
that goes in the well.
Yeah. Okay. So June 15th and June 16th again.
Amazing days across much of southeast Arizona.
What happened?
Well, we had Hurricane Bud, which briefly became a Category 4 hurricane for a couple days down in the East Pacific. Was drawn up. The remnants of it were drawn up the Gulf of California towards Arizona and just put us in some soup, moisture-wise, and caused a nice 2-day event across much of southeast, eastern Arizona, and a lot of New Mexico at the same time.
It seems to me, actually, that those storms don't recurve back eastward into the U.S. until later on in September-ish, October-ish is more characteristic of that kind of a trajectory. But as far as I can remember, it's, at least in recent memory, it's uncommon.
Yeah, I think that if you're going to get an event of this kind, you're going to get it either in June or you're going to get it in September. So it was a transition kind of pattern. So we had an approaching trough of low pressure, sort of that springtime weather pattern to the north that was still digging down into the southwest. We also had the tropics firing up, which is going to be definitely more of a summer. So it's kind of that collision of spring and summer across the southwest. So that trough approaching from the west, there was a little low pressure system, trough of low pressure off the California coast. A little upper level low pressure systems broke off of that trough, was over the northern Gulf of California. And so that interacting with the moisture from the remnants of Bud actually got sheared apart and moved off to the east of us. The moisture left over with this low pressure system, which brought some really cold upper level temperatures, was enough to really destabilize the atmosphere and cause several rounds of heavy, slow moving thunderstorms across Arizona on that Saturday on the 16th.
Now, was it also that there was a high pressure that was sort of in a favorable position so that the winds would actually sort of bend around the high and it actually helped direct that low pressure, the tropical storm into the region?
The whole subtropical high was sort of shifted off towards the east, and so you had a lobe over the southeast and a lobe over Texas. And so the trough then So that upper level flow would have been counterclockwise around the low and clockwise around the high pressure system. And so we'd be in between the gears of that. And that flow would have been straight north into Arizona. And so Bud was in the right spot. These broader synoptic situation, circulation pattern was really favorable to guide that moisture up in. And the associated dynamics with trough and the upper level cold temperatures, I think, really helped.
So then the Bud helped push in high precipitable water into the air. So a lot of moisture in.
Yeah, very little dynamics by the time it got up here.
Right, and so that's actually where we needed the trough to come through to actually create that uplift and to wring the sort of wet surface moisture out of the atmosphere.
I don't think there was I don't remember if there were a lot of dynamics associated with it, meaning looking at vorticity advection or some upper level support. There may have been a little bit of upper level support in sort of helping to lift the air, but I think that the cooler temperatures aloft associated with a lot of moisture at the surface can really lead to those steep, we call lapse rates, or changes in temperature with height, which are going to give you the ripe conditions to cause a lot of convection to occur. And so I think you could have had a Bud situation happen in the past where we'd had a lot of that moisture come in and we just get socked in with moisture. But if we didn't have quite the right amount of either solar heating to destabilize the surface or some other associated dynamics with it to cause a widespread convection outbreak. We've had in the past these tropical storms come up into Arizona with clouds, and they don't do anything. They just make it really, really humid. So I think that combination was really key for that event.
And that event actually was pretty widespread across Arizona and, as you said, New Mexico.
New Mexico too, right.
And then that was basically it for June.
Yeah. It goes in the monsoon season. I'll take it. But
you will take it, but you only would take it because it furthers your case here.
Yeah, absolutely. In any other case, it's not.
So I'll get you on the record.
You'll get me on the record.
Is that monsoon?
It's monsoon-y. It's not really necessarily associated with the monsoon in the sense of the broader circulation pattern with the subtropical ridge, the shift in wind direction, the onset and persistence of the dewpoint.
And then it disappeared.
And then it disappeared too. Yeah. So
that was a transient event to me.
Yeah,
that was all weather.
It was
all weather.
Yeah, it was very opportunistic. Yeah, with a tropical storm colliding with a mid-latitude type system. Really cool. Great. I mean, it was multiple rounds of heavy rain and light to moderate rain. So it really was, I think, pretty beneficial, but very short-lived.
Obviously, it helped some of the impacts on the ground, helped the fire situation.
I think the timing of it was spectacular.
And if you recall, that was right when we were in the midst of what was nearing to be a record dry stretch.
Yeah, we were almost in. That's right, because you were saying that we were within days of the longest for Tucson, right?
Yeah, if I remember correctly, it was something on the order of 110 days was the record, and I think we reached 106.
7 or 6.
Yeah, somewhere around there. That 2-day event, if you will, was basically then followed by 2 weeks, more or less?
Almost 3, and it's still
almost 3 weeks. That's right.
In some locations. So, and it's probably important to say too that there are parts of the state that didn't see that event and haven't seen anything yet. I mean, we're just now starting to fill in the gaps in the last couple of days. We don't quite yet have full precip coverage across Arizona, but we're real close with the last couple of days for the monsoon season.
So those areas would be sort of the northwest corner and maybe the Four Corners region?
Yeah, and in the last couple of days and the update from yesterday, the coverage really has increased quite a bit. There's parts very, very lower Colorado River out in like La Paz County, southern Mojave County that haven't seen it yet, but everybody else has had pretty much at least a light rain, if not more. So there was that big dry stretch and it got hot in between, and then we've really turned on the monsoon activity in the last couple of days.
Yeah, so if you look since 2000, that 9/10 of an inch at the Tucson International Airport, there's only 2 other years where there's been more. One of them was 2016. And that year, the monsoon came right at the end of June. You tend not to get precipitation in June all that much. I mean, if you look over the historical record, it's close to a tenth, in between a tenth and 2/10 on average in June. So we'll take basically what what we can get here.
Yeah. I mean, there were the precip cover. There were locations that had 2, 3, 4 inches of rain over that 2-day period in June, which, I mean, there would have been some local records broken for sure, depending on where you were at. The airport proper, though, didn't get as much as some other parts of even Tucson did.
June was another hot month for the Southwest.
Yep.
I think it was near record. Although my memory, it didn't seem like it was all that. We didn't have like a really big heat wave.
Yeah, I kept waiting for the Father's Day heat wave that we've had the last 2 years, and what did we have instead? I had 2 inches of rain in my house, so that was nice. That was a nice surprise. I'll take it.
I do recall you made the estimate or the forecast that the highest temperature in Tucson in June was going to be 109.
Yeah, I mean that was going into that particular weekend where it really took the edge off, and then once we got out of that, it didn't get as hot as I would have expected. It was actually in the first week and a half of July that the temps really did pick back up again, back into that sort of June territory that I expected to see.
So the high in June in Tucson was, again at the international airport, 107.
107.
Yeah.
So,
but it was persistently above 100, which is kind of par for the course.
Solid. 102s, 106s. Yeah. Through the end of the month.
I was bullish on the temperature. I went a little bit above that. I thought the high would get into the 110 region, but again, Mike, I think that we'll add that to your tally of victories.
It's all climatology, just going in my head.
First part of July, 111 so far has been the peak temperature.
Yeah.
So June was hot. When you look at Arizona in total, the 3-month average temperature has been the record, 100 out of 124 years. The 6-month total is record. So
solid warm year for sure.
Warm year, yeah. All right. So aside from that fortuitous assist from Bud, the monsoon basically started, at least here in the Southwest, July 7th, really in earnest. And we finally now have precipitable water at levels above an inch, persistently above an inch. Hopefully this will continue for the next couple of days. Mike, talk us through a little bit of the onset of the monsoon.
I think since the end of June and into the first week of July, we've been waiting for the circulation pattern to strengthen with the subtropical ridge sort of building past us and then to the north of us. And that is indeed what has happened over the last couple of days. We've had a real strong, broad ridge of high pressure across the whole country. So we've had really warm temperatures across the whole continental U.S. And so you've heard about the record temperatures in California that has led to power outages. There's been record temperatures, heat and humidity in the eastern U.S. And so as that ridge has built north of us, we've been in that strong easterly flow. Across both New Mexico and southern Arizona, we've had these just persistent, strong easterly winds over the last week where we had overnight winds of like 20 to 30 miles an hour out of the east. It was really kind of strange. And what it did is it helped keep overnight temperatures up. So you'd wake up in the morning, us weather geeks who look at the soundings couldn't tell a morning sounding from an afternoon sounding because they looked the same. You weren't getting that overnight radiative cooling and the temperature inversion that you normally see in a sounding. So this very persistent easterly flow has helped usher in some deep moisture from the east. And we've also had a seep of moisture up the Gulf of California. So, kind of out of the east, the southeast, the south, and then even out of the southwest, the moisture has been seeping into the southwest. Dew points have crept up over the last week. And as I said earlier, the 3-day dew point definition I think will be met today, which will roll it back to July 8th would be the official start date in Tucson.
That's somewhat late, actually.
It's 4 days late or 3 days late. I mean, that's pretty good.
I'll give it to you. I mean, we shouldn't be so
man, oh man,
so precise.
You had it down to you didn't say it was 72 hours late.
I was actually thinking just how remarkably consistent it is. Within 2 or 3 days, it's remarkable that the monsoon is always sorts.
I know. Why don't we have a clock, or like a ball that drops in New Year's? We could have like a giant hygrometer that we all rally around.
Let's go back to that the building of the high pressure ridge, because I think the California heat wave that happened over the weekend it's not something you see very often at this time of year, but yet you see the building of the high pressure ridge, and you sort of talked about it as the ridge sort of doing what it usually does, but yet what went on in California was somewhat unusual.
It's not unusual seasonally. I mean, the records were there, clearly. It broke records, right? But it doesn't stand out. It's not like this kind of event occurred out of season, so it was just shockingly. This is exactly the time of year you'd expect to see that kind of event. The magnitude of the event is clearly exceeding past events because of long-term trends in temperature and the climate change aspect.
Was that ridge shifted slightly to the west? Because my understanding is what was causing a lot of the record heat is that you got offshore flow.
Yeah.
And so you didn't get the sea breezes coming in and moderating the temperature. You sort of were under that easterly flow. And then obviously the high pressure ridge was causing that descending air, and
Absolutely.
descending air is creates atmospheric warming,
Right.
and that was part of it.
Yeah, the ridge has been wobbling around,
Yeah.
and as you'd expect it to see, it's not a monolithic thing that just sets up and stays in the same spot. And so, and that little bit of wobbling and that kind of offshore easterly flow is going to warm up Southern California at any time of the year. I mean, that's, in the fall and into the winter, that easterly flow would cause Santa Ana winds, the
Right.
offshore flow, right? So we had actually downsloping winds here in southern Arizona, which kept temperature that actually helped push temperatures up, helped dry out the lower atmosphere, helped kept overnight temperatures up. So it was unusually strong and persistent for a couple days. So that I think sort of stands out. But as far as the event itself, you could look at that weather map and pick it up and not look at it and go, that's super strange. It's somewhat seasonal.
All right. So what stuck out to you then, Mike, of the last 3 days of the monsoon?
Well, I think that
Besides that, it's here finally.
Yeah, I think as I was sort of
finally,
finally,
I threw that in.
You're 3 days late. Been waiting around for hours for this monsoon to show up. I got stuff to do. The thing that has been cool to see is the ridge setting up broadly, the moisture just following in, and then what we've benefited from was a little inverted trough or kind of a weak cyclonic flow on the southern side of this broad ridge that, again, it's moving from east to west across the Southwest right now.
Right.
So it drifted in from New Mexico and has been moving through Arizona the last couple of days, which has just wholly wall-to-wall good storm activity.
You get these inverted troughs moving east to west only when you have the ridge slightly to our north.
Yeah, so it's the kind of weather you'd see on the southern side of the broader subtropical ridge. So you're basically in the easterlies, right? You're now a subtropical climate. So anybody who's on that south side of that ridge is going to be in the subtropical climate with these easterly waves.
And these easterly waves are important because they create local dynamics, right?
A little bit. They're usually very weak, so they're not like low pressure systems in the middle of winter that are driven by sharp temperature gradients. They're usually upper level. They're usually very subtle in changing wind directions. They can produce changes in shear, which can help with storm organization. They sometimes can have a little bit of lift with them. Sometimes they can cause divergence or changes in upper level winds that will cause that lift. And often they'll have slightly cooler upper level temperatures. So a lot of those factors coming together with a lot of surface moisture will lead to environments that are conducive for organized storms.
The way I simplistically think about it is you need, if you have high levels of moisture near the surface, enough for there to be actual rain, if you can lift it, you need to lift that air. And these upper level lows can actually create a temperature gradient in the atmosphere that is cooler, it's a steeper gradient.
Yeah.
So it can actually help drive that sort of convection. But it also, as the divergence at the top, it also creates convergence at the bottom, which can help lift the air as well.
Yeah, I think, yep. And this is why the monsoon is so complicated, because it's driven by such subtle features, and it's interacting with topography, and it's interacting with these really steep moisture gradients, is that a lot of sun and a moist environment on the ground are often enough to drive convection and often enough to drive a thunderstorm. But that by itself can produce thunderstorms in some spots. The mountains very easily can convect in those situations. But if there isn't a little bit of shear in the atmosphere or some winds to organize the storms, they won't move off of mountains. They won't move into valley locations. You won't have any sort of organization of the storms. So these subtle features like an inverted trough, they can help create more widespread conditions for storms to actually organize over larger areas instead of having the sort of popcorn type thunderstorms that would form over a mountain and then we'd see them kind of fall apart as they moved into town.
Now, what about a couple days ago, it was basically a nighttime event. Not a nighttime, it was a late afternoon event. Past like solar convective heating.
Yeah, I think that at that point, sometimes it takes the very end of the day for you to reach the convective temperature or to start to have the storms push out outflows enough that will cause lift in the valley locations to then push back some of the limitations of the convection in the valleys. So sometimes sometimes you can have these things called caps where there's slightly warmer air left over up in the atmosphere a couple thousand feet, which would limit the ability to allow convection to happen freely. And so these outflows of cold air can be the little bit of a push to push up in the atmosphere and break those caps and then cause the convection, which is why those can be really good because you can have the convection occurring on the thunderstorms over the day and then the outflows will finally progress into the valley locations when they've been maximally heated. So they're just like ready to go and this outflow kicks it, and
just
then
a little bit of a nudge.
Yeah.
That's kind of what you need at
right.
times.
And sometimes if it's too wet here, what we can have, and there's no cap, is that you can get convection, like you get a bunch of clouds that form by noon, and it just sort of shades everything out, and then it just kills everything.
I guess we should then tally.
Yeah.
And so we're over 2 inches, as you said, across parts of the metro area. Over some places have been over 3 inches in the valleys. Not on obviously as you go up higher at tops of the Catalinas at Kip Peak, it's going to be a lot higher than that. But particularly out in the western part of the valley, there are some stations 2+ inches.
Well, that's the thing.
Not some stations, some observers. Like thinking about like rain log.
Yeah, a couple of our rain log observers in the northwest part of Tucson, and this is actually in between the flood control gauges, have reported 2.5 to 3.5 to almost 4 inches of precip in the last couple of days. Mm-hmm. And the top of Mount Lemmon, north of Tucson here, has only had about a third of that. Just a little over an inch.
Really?
So yeah, so it's this strong easterly flow has not allowed the storms to park over the mountains. They've moved out quickly and into the valley locations. And we saw that huge 2 days of severe weather outbreaks across the Phoenix area, including that big event yesterday.
Well, yesterday was
see the pictures of the huboobs?
Yep.
They were a spectacular organized line of thunderstorms that came out of the mountain ranges east of Phoenix and moved quickly west and just raked across the city. A lot of wind with that particular event.
I think there were gusts up to 80, 90 miles an hour.
Closed down the airport for a little while, canceled some flights. They had a lot of power outages and more severe weather in Tahan Autumn to the west of here. So it has been really interesting. The last 2 days, most of the activity has been kind of from the west side of Tucson out across the rest of the west part of the state. So
that's been another, you mentioned the easterly winds. I mean, that's been a persistent character so far in this season. And I don't remember, I'm sure that this happens quite frequently during monsoon seasons. You can actually get winds from all directions.
Yeah. I think you typically have a sort of that weak easterly flow, though, and it can enhance and weaken, but it generally is out of the east. But we can have these situations in southeast Arizona, though, where you do have strong easterly flow with easterly surface winds that will be downsloping and actually can dry out the atmosphere. And that has subsided in the last couple of days, and so has put us back into a much more favorable environment.
Okay. Anything else about the onset of the monsoon? We're 3 days into it, more or less.
It's solid right now. It looks great. And it's interesting if you look at the forecast over the next week, if you look at the Climate Prediction Center, and they're 6 to 10 today, the 8 to 14, the 3 to 4 week, the 1 month, and the 3 month all have above average precip for Arizona. For all of those time periods, it kind of cuts New Mexico in half. So it seems to suggest that Arizona is going to be in this more sort of favorable monsoon regime somewhat persistently. That, of course, is going to mean it's going to be up and down every day. Some places are going to win. This looks real promising. Yeah,
let's hope it has some staying power.
Staying power, filling in, starting to beat back the drought conditions across the state and starting to make some progress on that.
So I wanted to get into the drought about some other impacts.
How do you have to ruin such a good podcast? We have to talk about that.
But before, I wanted to ask about precipitable water in the atmosphere being sort of a key metric that's needed to really have convection or widespread precipitation.
Precipitable water and that number is going to vary by elevation too. So if you get to a lower elevation, you need more precipitable water because you have more atmosphere. So to get the same amount of instability, and if you go up in elevation, you actually have lower precipitable water because it's a higher elevation. So it's actually not a magic threshold. It would actually depend on the elevation and how that would translate into the thermodynamic instability in the column. But I think what you're alluding to is that higher precipitable waters lead to more potential for moist instability in the environment. So as you get up to, we've had precipitable water, you get to August and later in August and into September, we will have days where it's 2 inches. Those would be record days, but those are days where you just need a slightest little nudge and the atmosphere can just go off. Very soupy tropical, very, very unstable, just kind of automatically.
All right. Well,
kind of made all that up too. So,
well, we've had precipitable water above an inch for a number of days so far.
Yeah, it's felt like it. It feels like early July. This is super promising. It's not one of those kind of twiddling our thumbs waiting for.
But if we learn anything from last year, it's that this can end abruptly.
Yeah. You were worried about it being 65 hours late. And now you're going to jinx it, and it's just going to disappear for the rest of the season. So thanks. Appreciate that.
Yeah, well, I'm here for you, Mike. The onset of the monsoon season usually coincides with the improving of fire risk.
The annual improving of the drought.
and drought, right? Because so the fire season, for the most part, is on its...
Should be on its heels for sure.
Yeah, should be on its heels.
I think we should be in rapid retreat as long as we can keep up the moisture. We should start to see the forest closures rescind back to camping and all that kind of stuff.
This year, Arizona has burned less than New Mexico, about 85,000 acres. I can't remember what it was a month ago, but it was below average then too, as it is now. New Mexico, on the other hand, has been about 350,000 acres. So it's been a more active fire season.
Had some big fires
in New Mexico.
Yeah.
That was basically the opposite of last year. Arizona had close to 400,000 acres burned, and New Mexico slightly over 100,000. In Arizona, about 20% of the total acres burned all year happened after July 1st.
Really?
Fire started after July 1st.
No kidding.
So while peak fire season, as you say, is on its heels, it's not to say that there won't be fires and that there isn't fire risk.
That's a good call.
Particularly in those places that you mentioned before that haven't yet received a good dousing from the monsoon. And who knows, this could end. I mean, the short-term forecasts look good, but you get a long 2-week dry period, and we can be right back in that elevated risk.
We're talking about epic 8-month drought conditions, almost complete lack of winter moisture in some locations. So a couple of days of monsoon rain may not do it, may not be enough. Certainly requires some vigilance at the beginning of the season. The background humidity, though, is going to radically help, if anything. I don't think you're going to get real problems with control. There may even be some use for wildland fire use as the conditions have sort of shifted in the season here.
And the wind dies down.
The wind, absolutely. So you're going to have erratic outflow winds and near storms, but you won't have the broader howling kind of winds that we'd get in the April season out of the Southwest.
Okay, so drought. Last month, June 5th, there was about close to 74% of Arizona was extreme drought. or worse, extreme or exceptional drought. So 73% in extreme or exceptional drought. Fast forward a month and picture has not changed. Despite the fact that we had a pretty widespread, mid-June event that happened in somewhat unusually within a dry month.
Right.
Is this unchanging drought picture a reflection of just how severe the drought was coming into June, or is it just too early to adjust the drought picture based on one event?
Yeah, there's been a lot of discussion about that. That event kind of came in, and there was discussion about trying to start a nibble around the edges of the drought depiction in Arizona. I was involved in some of those discussions, and I think that there was just sort of a consensus of that's a step in the right direction, but not quite enough consistency of precipitation to make some big changes. And so I think we just kind of held steady. There was a concern too, and I talked to ranchers and some land managers and some different ecosystem scientists, ecologists, that there was concern about having that widespread rain in the early part of or mid part of June causing some phenological changes, stuff to start growing.
Like a false start?
Kind of like a false start.
Like, the monsoon's here.
Yeah, so stuff germinating, stuff starting to grow, some change in, rangeland productivity. And, it's quite warm at that point, and it took 4 weeks to have subsequent follow-up and soil moisture. Stuff could have tanked in that situation. So I don't think we really had that issue. So the precip coming into the state, I do think we're going to be able to start to. It's one of these things. It's going to take. I would wait till the end of July to see how July.
What if July's average?
If July's average, I think we would make some very small incremental changes, and
it's a reduction in the severity.
Yeah.
Even if you did that, the whole state would be under some moderate or extreme.
I think you'd look at the pattern of precip across the state, and I think you'd start to try to move some of those boundaries, slowly degrade them back or improve them a category over time. Drought monitoring and drought depiction is a very tricky business because the summer rainfall is important to some things, and the winter rainfall is important to other things. Some are important to both. And
it's like multidimensional.
It's very multidimensional and it's very contextual. So if we start to erase drought conditions that formed over the winter with summer rainfall, that's quite meteorological to think that way, but it may not necessarily reflect that you've had large changes and impacts that have occurred.
You kind of need a map for each particular
you kind of do
impact that you're
absolutely.
If it's fire, if it's water, if it's rangeland.
I agree.
If it's mood. Psychology.
Mood. Yeah, totally. The mood. Well, we've talked about this. If it doesn't rain every day in Phoenix and Tucson for the rest of the monsoon,
the anger index, our dismay or monsoon disapproval index. Yeah. So what would it take to make some widespread changes? Like, are we talking like a couple inches over like 150% of average, 125% of average? Or?
It's going to be hard to ignore it if we have the whole state at average to above average, or not the whole state, but there are going to be regions that are going to be average to above average. Those above average, by the end of the July, I would expect that we would start to nibble at those. But again, as I said, we will improve those from a climatological, meteorological standpoint, but it doesn't mean that the impacts that have accumulated or were caused by the winter have necessarily been ameliorated.
Right. And just for comparison here and comprehensiveness, New Mexico's drought picture has also remained largely unchanged from a month ago, and it's about 58% in extreme drought or worse.
It's asynchronous too. I think the kind of the way we think about this in the depiction of drought. If we were drought free in June and we went into July and the monsoon was 3 weeks late, and we had deficits that were like half of 50% in July.
Would that be 25%? Half of 50%?
I did say that.
I know what you meant.
The higher math. Thanks. Yes, half of 50 is 25. I think I meant to say 50 or 25.
I know.
Thanks for the correction there. That could be a situation where, since the seasonal timing of precip is pretty dialed in, right? We've been talking about that we didn't have it, and it's running that late. I would be in favor of moving drought in fairly quickly. But on the improvement side, I'd like to go slow, right? So you can have rapid onset of this out depending on the season. Like, I think it's harder to say that you have that happen in the winter here. But in summer, since seasonality is so stark, and especially in some places, and some systems really rely on that I think you could move drought conditions and show a different type of impact than you would, say, in a slow onset kind of winter drought or over a period of years.
I mean, the people that think about this and try to create these pictures from a very nuanced perspective is like, I just have a lot of respect for it.
It's very hard. Yeah, it's a very tricky business to do. Just to keep on it.
And you can't really do it by looking at one metric or even trying to do it objectively, because all of those, let's say just, a precipitation or a temperature, like that doesn't capture it in enough detail. And
no, and there's
monitoring gaps. Yep. And, you really have to kind of have your boots on the ground to really understand. And plus, it comes at it from different perspectives, like a ranching or a fire or water managing.
Absolutely.
or whatever.
Yep, totally agree.
Okay, Mike. Well, I'm glad that we've got you behind the helm, or maybe I'm not.
I'm not sure you should be all that thrilled with that. Yeah, I think that's. You should
if anybody has any complaints on Mike Crimmins, you can find them.
I get plenty.
All right, so wrapping up here, let's just think. You sort of already alluded to this, Mike, with the forecasts, but there are sort of rosy pictures looking forward, at least through the end of the monsoon season, and then even further out in terms of elevated chances for rainfall. Now,
we should caveat this.
Yeah.
Go, you do it.
Well, I'm sort of, when I see those seasonal forecasts in the monsoon painted in increased chances for above, like, I'm always like, well, what is behind that? And I know I looked at the models, and all of the models, except for one of the Canadian models, part of the North American multi-model ensemble, like, has this wet signal, and I don't know. I don't know what's in, like, those models are like black boxes to me. So
what's in the sauce?
Yeah, like, what's the mechanics behind that?
I don't know. I think we had read coming into this later part of the spring that there is an East Pacific tropical connection, and if you look at the models, there is a plume of moisture that extends from the East Pacific up into the Southwest. So it's not teleconnected, it's literally connected. So I guess that's what the models are picking up on.
It's like you look at all of them, again, except for one of the Canadian models, and they're all picking up on a kind of a robust wet signal. So yeah, later on in the season, we're getting into maybe picking up on some of the impacts of a developing El Niño event, which is increasingly looking more likely, looking at the latest forecasts from the Climate Prediction Center and the IRI. Most of the statistical and dynamic models are all pointing toward
it's like a solid moderate,
a weak to a moderate El Niño event. There's a warm pool of water beneath the surface, gives people confidence that the mechanisms there are in place. And, through the winter, the chances, the IRI and the CPC have it at close to 70% for an El Niño event. So I don't know. It seems like we've been every other year now in an El Niño event.
Exactly. Who cares?
Whatever happened to this 3 to 7 year
of neutral? I don't know. It seems like we're on track. We're wandering back and forth between weak, neutral, Godzilla, weak, neutral, La Nina. So all checks out.
Okay, it's all how as we would expect.
Sure, why not? That warm pool of water is there. It certainly looks like it's on its way and emerging in the East Pacific. I think that the interesting thing is going to be, and I think what we've learned all too well over the last couple of El Niño events, is where the worm pool is matters, and so maybe that'll help us, treat this one a little bit more with some nuance.
Okay, so what's your thought going forward?
Climatology.
So boring.
I know. I like predictability. I go for central tendency.
So if you went to Vegas, what would you bet? There's no climatology in Vegas. You can't what would you bet on?
I'd
Vegas?
Probably just split half on one and half on the other, right?
Then you're guaranteed to lose.
I'm guaranteed to lose. Of course I am. But that, at least I know the outcome.
Because the house, you forget about the house. I guess
true.
in climatology, there's no house, huh?
No.
Again, going back to our sort of monsoon wager, it's certainly looking good for you thus
it's
far.
looking good for me. All that green on those maps?
Any wager? Okay, so the wager is how many days in June and total amount in June.
Wait, in June or July?
Sorry, July.
I don't want to
go back to June.
10 days in July with measurable precip.
And then the total amount?
3.5.
3.5. Wow. Okay, so what did you say was the total number of...
I said 10 days.
No, not you, but
the total monsoons in about 25 days with measurable precip in
Right. So
Tucson.
it's about every fourth day on average. Because there's
108 days.
Yeah. So it's close.
Yeah. Yep.
So you're going a little bit higher.
We're on a roll here. It's persistence. A little better than climatology.
I'm going to go 12. I'm going big.
Okay.
And man, do you know what it was last year? Sure. Yeah, 6.8 I have. Wow, that is incredible.
It is incredible.
Well, I'm going 4.
All right.
4 inches, 12 days.
You just edge me out on the high side. Fine. We'll see what happens.
All right. Game on.
Game on.
All right. Thanks, everybody, again for tuning in to the Monsoon Edition.
Monsoon Edition.
2018.
All day, all the time.
Giddy up.
That's right.
All right. Have a good July and June.
The Southwest Climate Podcast is a production of CLIMAS, which is part of NOAA's Regional Integrated Science and Assessment Program and is housed at the University of Arizona Institute of the Environment. Mike Crimmins is a principal investigator with CLIMAS, a professor of soil, water, and environmental science in the College of Agriculture and Life Sciences, and climate extension specialist with the University of Arizona Cooperative Extension. Zack Guido is a research scientist with the Institute of the Environment and UA program manager of the International Research and Applications Program. The podcast is edited and produced by Ben McMahon, Research, Outreach, and Assessment Specialist with CLIMAS.
The monsoon. Let's take this again.
We're going to need to.
I didn't quite go over that.
It went somewhere straight down, just like drought.
Take 2.
Never goes up.